Hello everyone, greetings for the day. Welcome back to the tutorial of ISTQB Foundation examination. So we are finally at chapter 4 with understanding on the next topic, beginning with the white box or structure-based techniques. So we are done with the previous tutorials with the specification-based techniques. You are free to put your queries down below the comment box to understand them in case you have any more queries about the same. But finally, in this tutorial, we'll be moving with the structure-based testing techniques. And the very first thing what we are going to understand is what are the techniques we are going to cover here. So we'll be having two techniques to understand that statement testing, are also called as statement coverage, and decision testing, or also called as decision coverage, and also called as branch coverage. So we have just two techniques to understand from the foundation syllabus. We do have more techniques which will be covered as a part of advanced level. So as of now, you are limited to the two techniques, that is statement testing and decision testing. Beyond that, obviously, we'll be understanding each one of them separately in an independent tutorial so that we don't get confused with it. And in case you have any queries, just let me know. So understanding few of the very important terminologies and statements about these two techniques, which are very helpful for you to answer the theory-based question from this segment. Starting with the first one, it says obviously understanding that what is statement testing is all about. It is to test the statements for a given fragment of code. Now, when we say fragment of code, these are white box techniques where it is used by the person who knows the structure, has the knowledge of structure, understands what is the code, and based on that, it tries to implement such techniques at the code level. So obviously, very commonly performed by developers. Whereas the other technique, decision testing, is basically to test the decisions made within the fragment of code. So there's a difference, team, when you talk about what is statement and what is decision. So statement is something as a part of code. What you see each line of the code is written is called as a statement. But certainly at certain point of time, there are some decisions made that if this satisfies, then you move to next. We call it as decisions. More, we will look into that when we have a certain fragment of code in the examples. We will look into that in more detail. So decision testing is also called as branch testing. It's a synonym of decision testing, so keep an eye on that. It can be also called as branch testing or branch coverage. Decision testing is considered stronger compared to statement testing. The reason is statement testing only limits that self to the statements, whereas decision goes to the path where we don't have the statements as well. So we will be having a better understanding when we look at the example, but for now, just keep it into consideration that decision testing is considered as more stronger compared to statement testing. Whereas, obviously, there's another statement which we consider as a part of comparison between the decision testing and statement testing is that 100% decision testing coverage guarantees 100% statement testing, but not vice versa. Just looking at the previous point when I said decision testing is stronger than statement testing, considering this point into evaluation of the fifth point or the last point here, obviously if 100% decision coverage is done, then 100% statement coverage is also done, because decision testing is stronger than statement testing. So, but not vice versa, being statement testing being weaker than decision testing. Obviously, if 100% statement testing is done, it does not guarantee 100% decision coverage. So let's quickly look into some of the understanding in more better way so that these statements can be refollowed and understood in more better way. So here I'm taking a simple and sample fragment of code where there are two variables which are being read at the beginning. So here we call these things as pseudocode. A pseudocode is something where it is not mandatory. It is as per the syntax, as per the standards, as per the protocols of any programming language. It's just to make you understand that this is a piece of code. That's all. But at any point of time, you must not be evaluating the code given to you. You must be just working it out and getting the statement coverage or decision coverage. So repeating it again, it's just a pseudocode. You are not supposed to check for the syntax errors in this program and consider that the question or program is wrong. So here we have a very simple program. Hope everyone understands that we are reading two variables, A and B, and there's a condition check. If A is greater than B, then print A is bigger, else print B is bigger, and end if. So the very first thing what you have to do is you have to convert, when this question is given to you, you have to convert this question into the program into flowchart. And a simple flowchart would look something like this, where it has the various statements being defined, and the other part of it is like the directions, orientations which a program will follow. So following the more better protocols of flowcharts, we put the start and end of the flowchart, which says that this is where it starts and this is where it ends, and that is a particular program. A flowchart basically consists of two major aspects or two major inputs, where we can say that the one which you see as the directions or the arrows or the lines within the flowcharts, all the lines are called as branch or edge, or maybe you can also call it as decisions. So it can be called as either branch, edge, or decision, which is one of the part of the flowchart. Other than that, it consists of the boxes or the enclosed figures here, which are called as the nodes, or also called as statements. So the boxes basically are called as statement, and the green color, all the lines are called as conditions or decisions, which will be tested as a part of statement testing and decision testing. So let's understand statement testing in more better way by following that how minimum test cases for statement testing is achieved. So usually they ask you what is the minimum number of test cases for 100% statement coverage. Now to measure that, considering the same example, we first of all have to understand what is a path. So a path is the executable path which reaches the end of the code starting from the start point. So if you look at the flowchart, we basically start from the top and reach till the end of the flowchart by following the directions. And that's what you call it as a path. So starting from point A and reaching point B is what you call it as a path. So let's see what are the different paths. So this is what we call it as a path, where you start from the top and reach till the end, and we call it as one path. Now there are obviously an alternate path which goes like this, which is from the false. So if the condition is met, it is true, it will come straight, whereas if it is not true, otherwise false, will be going from the else statement and reaching the end of the program. Now let's come finally to the statement testing, and we are talking about one of the understanding of the precise question which you can see in the exam. So finally, this is one of your example, like the piece of code is given to you, the same program we are using still, and the question at the bottom which will be having like what is the minimum number of test cases required for 100% statement coverage. So this is your flowchart, and you have to just try with minimum number of paths to cover maximum nodes, or all the nodes basically, where nodes are also called as statements. So SC is measured as minimum number of paths required for covering all the nodes. So let's take one path which covers the maximum nodes at this point of time. Yes, the path 1 basically covers the maximum nodes, but we are supposed to cover all the nodes. So we have one node in the else path. So let's take one more path which would cover the entire thing. So finally, SC is 2. That is, statement coverage is 2. We need minimum number of 2 test cases to have 100% statement coverage. That is to cover all the nodes. So all these boxes must be covered so that we can call it as 100% coverage. And minimum number of test cases required for this scenario is just 2. Let's look at some more questions. It's the most simple thing what you can be asked with, which is a single if with else statement. There are various other possibilities like single if without else, multiple if, nested if, unnested if. So let's look into that. So moving to the next example here, here's a scenario of ATM, that's automated teller machine, where wait for a card to be inserted. If card is a valid card, then display enter pin. Entering the next condition, if pin is valid, then select transaction, else otherwise display the pin invalid, otherwise reject card. So remember team, here the first if starts, if it is true, the second condition is checked, that is second if, and once the second if is closed, then only the first if will be closed as per the protocol of simple programming. So this is the flowchart for this, where you can understand and relate the program in here, and each statement written in the program, the piece of code given to you in the question, is basically a statement. And that's why we call it as statement testing. And here each node represents each statement here. And we need minimum number of test cases to have 100% statement coverage. So obviously, you will be needing, let's measure how many paths we would require to have 100% decision coverage. So first of all, I would need one path like this, reaching the end. That's covering the 3 statements here. Then the second part would go something like this, which will come here, and then it will come down. Then it will reach here. Whereas the third statement, because we are still left out with this node, and we need to cover all the nodes here. So obviously, we'll be going like this, coming down, and then moving down from here and reaching to the end point. So that's what we say statement coverage is 3. Because obviously you need minimum 3 paths to cover all the nodes. So it's all about, like, when they say how many or what is the minimum number of test cases to have 100% statement coverage, you need to give the answer as 3. Sometimes they can ask you, like, what is the coverage, 50% statement coverage. Then you should say 1.5, but 1.5 is not the possibility. So they won't ask you such questions. Subjected, the answer is 4 test cases for 100% coverage. You can say 2 would be 50%. But we'll look at this that type of question, and then we'll make you understand. So let's proceed ahead. I'm giving you a simple tip here. That is, statement coverage can be also measured without help of flowchart. So if you don't want to create your flowchart and then utilize a lot of your time during the examination, you can use this formula, which is given at the bottom, that statement testing can be measured as 1 plus count of else. So all you have to do is the given question to you, you just have to count number of else present in the program given to you and just add 1 to it. And that would be your answer. So that's a small tip, very simple example to apply it anywhere when you get it. You can thank me for that, no problem. So let's move to the next one, example 2. We have got nested ifs, that is multiple nested if without else statement. So that's a different scenario. Let's look at the program for that. If you see here, we have got read a greater than 0. If it is true, it enters a is equal to 21. If it is true, it will print something that is key, and then it will come out. Otherwise, it will just come out to the end. So there are no else nodes here. Now, for this case, to have 100% statement coverage, I would just need 1 test case. So it will go just from the outside and reach here. And that's just 1 test case required for 100% statement coverage. Because all we have to do is we have to try with the minimum number of test cases for all the nodes coverage. And that would give you the answer for statement coverage. Let's look into the third one. We have got 3 ifs here, and also applying the formula also, you can see that the number of count of else was 0. So 1 plus 0 is equal to 0. So anyways, let's look into the example 3 now. We have got a complicated example here where we have got 3 ifs, but only 1 else statement in between. So what would be the right answer for this? Let's see. The flowchart would go something like this, where we have the else at the B0. We will be having a print option, that is for the print B part. And we need to measure the 100% statement coverage with minimum number of test cases. So obviously, there will be 1 test case covering the maximum possibility, going something like this from the outside, which covers the maximum nodes. But we are left with 1 more node, that is print in center. So I would need 1 more path, which will be going from a different color. Let me represent, which will be going like this, which will come from here, then go here, and then come out, and then join here and come back to the end. So we need at least 2 test cases to have 100% statement coverage. And anyways, applying the formula also, we have 1 else statement here. So obviously, 1 plus number of else is equal to 2. So the statement coverage is equal to 2. Let's look at the other example if you're still not sure, which is like unnested multiple ifs. So I have two ifs, but if you see, the first if is getting closed, then the second if is getting started and closed. So this is what we call it as unnested multiple ifs. It is not within each other. So the program for that would, flowchart would go something like this, where you see we have got the different example, and those number of test cases required is one which I will take directly inside, covering the maximum nodes, and the second one would be I'm sorry about that. Second one would be going only from the outside, like this, then coming out, and then going out. So we need just two paths here to have all the nodes being covered. So you don't have to really try with, we can be having more paths, like one going inside and then just going from outside, one going inside and then again inside or something. But that is not statement coverage. That is cyclomatic complexity or multiple condition coverage. But at this point of time, you are understanding what is statement coverage, and it is limited to that. Whereas the formula, what I've told you for the earlier cases, would not apply here. Here, the new formula, what we can see, is different than the previous one. So the new formula says statement coverage, it will be either 1 or 2 in any of these cases. That is the unnested case, where when else, even if one else is present, the statement coverage will be 2, and if no else are present there, the statement coverage will be 1. The use of these formulas are only to minimize your efforts to prepare the flowchart and then get the answer. If you can remember the formulas, it will basically help you to get the answer directly without drawing the flowchart. Anyways, so that was just from the segment of statement testing, and we'll be looking into the more options of statement coverage and decision coverage. Let's look at the last possibility of the question, what you can expect in the examination. That is, for the given fragment of code, following path or test cases have been executed so far. What statement coverage is achieved? So team, previous questions you have learned that the scenario says, what is the minimum number of test cases required for 100% statement coverage? But here, they are giving you certain test cases which are executed, like implemented or tried with. Now they are asking you, based on these test cases executed, what is the achievement of the statement coverage? What percentage we have achieved? So the options will be having the percentages instead of number of test cases. So let's look at this case. The diagram will be the part of the question itself, and they will ask you the scenario based on test 1 and test 2. So if you see here, we have got test 1. So let's see what we are covering in test 1. A, B, C is the covered path. So it basically has covered 3 statements here. And the second test case goes with A, B, D, G, H, which is this path, A, B, D, and then G, H. So we have covered all these nodes here, 1, 2, 3. So let's eliminate them, which will be easy for us to recall and understand. So G and H. Now if you see, we have covered only the 1, 2, 3, 4, 5, 6 nodes or 6 statements from this program in these 2 test cases as per the given question. Now, how do you measure the percentage of the statement coverage? The formula is number of statements executed or exercised divided by total number of statements. So the count of total statement here is 8, whereas A, B, C, D, E, F, G, H, I makes it up to 8, and we have executed or practiced only 6 statements out of this, and 6 out of 8 statements are tested here, which is basically you can divide 6 by 8, which will give you the answer as 75. And that's the answer for this question. So sometimes they ask you minimum number of test cases, sometimes they ask you the percentage of execution achieved. So I think I've taken enough examples to make you understand, which you won't find in any other tutorial. So, maybe still if you think at this point of time that you need more clarification or more understanding, you can just take a snap, put it in the comment box, or push it to me over the mail or something, and I will be able to understand you and give back the answer to you with the justification and explanation on that. So feel free to reach me for any clarification, any understanding, and I will be really happy to assist you with the process of that. So stay tuned for upcoming tutorial. The very next tutorial will be talking about decision coverage, and which will be quite similar, but instead of statements, we'll be testing the decisions. So we'll understand all about decision coverage or decision testing or branch testing in that tutorial. So stay tuned, team, for the upcoming tutorials on ISTQB. Thanks for watching. This is all for now. We have more videos coming up on the upcoming tutorials and also on the upcoming chapters of this tutorial. So stay tuned for more videos. Do hit the bell icon for getting notified about the latest videos. And in case you have not subscribed to the channel, please do subscribe as early as possible, because we'll be having more videos about technologies and testing coming up back after this, right after this. So stay tuned, and till then, enjoy learning. Happy learning. Take care.